So this topic is about the vector addition. Vector, we know the quantities which are having a direction, we call them as vector. So if we want to add vector or resultant of the vector, you can also say vector addition or resultant of the vector. So it depends on the vectors. Like example, if two vectors are acting in the same direction, what we do to find the resultant, we add them. Example, we know force is a vector quantity. There is an object which is experiencing a force of 3 Newton.
Mr. The vector is like the direction, yeah?
Yeah, the vector quantity is having a direction, a quantity which is having a specific direction, we call a vector quantity. So example, there are two forces, one is 3 Newton, another one is 2 Newton. They are acting in the same direction. And the question is, find the resultant of these vector. Find the result of these vector or find the result of the force. So what is the result? How we will find the result of the vectors? If two vectors are acting in the same direction, to get the result, to find the result, what we simply do, we add them. So when I add 2 Newton and 3 Newton, both are acting towards right. So what is the result of 2 Newton and 3 Newton which are acting towards right?
5 newtons toward the east.
So it will be 5 Newton towards the east, or it is 5 Newton towards the right hand side. So when two vectors acting in the same direction and we want to find the result, so how we find their result? We simply add them. Is it clear, the first part, the addition of the vector? Anyone having a doubt or
Yes,
a
sir.
question? The chat and the mic both are open. You can mention if you have any doubt. So this is the first way of
No, thank you, sir. It's clear.
Okay, this is the first way of adding a vector. If two vectors are adding in the same direction, to get the result, we add them. But what will happen if two vectors are acting in opposite direction? To find the result, we subtract them. So if there was the same question that two vectors are there, one is 3 Newton, which is towards the right hand side. Another one is 2 Newton towards the left hand side. And the question is, find the resultant. So when we want the resultant, the result of these two vectors, so to get the result, we subtract them.
Mr. Subtract 3 minus 2 equal 1 newton toward I think the right, because
Yeah.
the biggest value is 3.
So 3 Newton is towards right and 2 Newton is towards left. So when we take the difference, so it will be 3 minus 2, which is 1 Newton. And the direction of the resultant is always toward the side where the vector is greater value of the vector. So 1 Newton towards right hand side. So this is the resultant vector. Is it clear, the second part?
Yes.
So
Yes, sir.
another example. A 20 Newton and 5 Newton. What is the resultant vector? A 20 Newton and 5 Newton. Both are acting.
25 Newton.
25 25.
So Mr.
25
15
Newton,
Newton
right.
no, we will add them because they are the same direction.
So they're in the same direction, so we simply add them, and when we add, it will be 25 Newton. But if we have a 20 Newton, the same question was there, a 20 Newton and 5 Newton in opposite direction. So what is the resultant here?
15 Newton to the right.
So it will be 15 Newton towards right. So we subtract them. So it is easy, like if they're in the same direction, we add, but if they're in opposite direction, we subtract them. But there's also a third condition. If two vectors are making some angle with each other, to find the resultant, we use a scale diagram. And what is a scale diagram, how it can be used, that we'll discuss now. And for that purpose, I want everyone to have a ruler, scale, a protractor, compass. So example, we have an object, and this object is experiencing a force of 5 Newton and a force of 20 Newton. And it is making angle, say 40 degrees. So two vectors are there, they're making certain angle with each other. So to get the result, to find a result, what we use a scale diagram. What is a scale diagram? From the name you can understand. When we say scale means like you measure something. So we make a scale, we make a measurement, that's why we call that as a scale diagram. And scale diagram questions can be solved by two ways. One is called a parallelogram method. Whenever you are solving a question related to scale diagram, so there are two ways to get the result. One is known as the parallelogram method, and the other one is known as triangle method. We will discuss both of them, but in exam you don't have to solve question with both. It's up to you which one you find it easy. That method you will use. But I prefer.
يعني Mr. the two methods are true.
Yeah, both methods will give you the same answer. But I advise you to use parallelogram method, which is relatively easy method as compared to triangle. But both methods are acceptable. Both methods will give you the same answer. It will not make difference. Now, what is the concept of the scale diagram? Whenever two vectors are making certain angle, so we'll use a scale diagram, and scale diagram can be solved by using a parallelogram method or a triangle method. So first we'll do
Mr.
yes.
If we are making the triangle, we will make half by base by height.
No, I will explain. It's not always a right angle triangle. We don't need area. There's a method, there's a technique how it is done. I will explain both techniques. So now the scale diagram using a parallelogram method. So first we'll do most of the questions scale diagram with parallelogram, and then after, once you have a better understanding of a parallelogram method, I will explain you the triangle method. So there was a question here, example, there are two vectors it is not necessary I draw the object. I'm just drawing object for you so you understand the question. There are two forces, two vectors are there. One is example 10 Newton and another one is 15 Newton. Or one is 9 Newton, another one is 15 Newton. And they're making angle between them is 60 degrees. Now what are the steps? What steps we will follow? The first step to solve this, we are using a parallelogram method. So what is the first step? Select suitable scale. What is the meaning of select suitable scale? On your ruler or the scale, you have marking in millimeter or centimeter. There is no marking in Newton. Like on your scale, it's not written 1 Newton, 2 Newton, 3 Newton. So you cannot draw 9 Newton and 15 Newton. There is no scale for that. So what we do, we select a scale. Example, if I select 1 centimeter, and it's up to you. Any scale is suitable. A suitable scale is acceptable. Not too small, not too big. According to your paper size or notebook size, you would select a scale. Example, I select 1 centimeter is equals to 3 newtons. So if I select 1 centimeter is 3 newton. 9 newton, how many centimeter will be there in 9 newton? If 1 centimeter I select, so there will be 3 centimeters. And about 15 newton, how many centimeters are there? 1 centimeter is 3 newton. So 15 newton will be how much? It will be 5 centimeter. Is it clear? The first part we discuss, we select a suitable scale. And this is not always fixed. It changes according to question. Like another student might select that 1 centimeter is 2 newton. So if 1 centimeter is 2 newton, then 9 newton will be how much? It will be 4.5. And 15 newton will be how much? It will be 7.5 centimeter. So any scale is acceptable. A suitable scale is acceptable. Is it clear? The first point that you select a suitable scale. You select that 1 centimeter is how many newton. So example, I select 1 centimeter is 3 newton. So 9 newton will be 3 centimeter and 15 newton is 5 centimeter. Is it clear?
Sir,
Any doubt?
can you repeat again?
Yeah, sure.
Can you repeat the explain? Can you repeat it?
Yeah, sure. Look, what happened in a scale diagram, that's the question is, there is a force of 9 newton and there is a force of 15 newton. And they're making the angle between them is
Mister, this is the scalar or a vector?
always this is a vector diagram, always for use for vector quantity. For scalar quantity, directions are not there, so we don't use it. It's always for vector quantity.
Yes, okay. But Mister, the arrows is representing the directions, yeah?
Yeah, arrows are representing the direction. But first thing what we do, we select the scale. Suitable scale, because like example, it is written 9 Newton and 15 Newton. But 9 Newton and 15 on your ruler or the scale, you don't find it is written 9 Newton. What is written? Like example 0 0.1, 2, 3, 4, 5 and so on in centimeter or millimeters. But you don't find your scale in Newton. So what you have to do, first you have to convert this Newton into centimeter. So how you convert this Newton into centimeter? By selecting a suitable scale. So example, if students select that 1 centimeter is equals to 1 Newton. So 1 centimeter is 1 Newton, then 9 Newton will be how much? It will be 9 centimeter. And
Yes,
15
Mister,
Newton
will give us a formula or
they
we
will
will.
not, you have to select. Some questions they provide, but most of the question they expect you to select a scale. So 15
But
Newton will
Mister,
be 15 centimeter. Yes.
but Mister, the Newton is weight and centimeters is
Is
like
a length.
this.
Yeah, it's a length. But that is the point here we called why, that is the reason why we called this a scale diagram, that if it is Newton or any quantity is there, what we convert them into a scale, into a measurement. That's why we
Yes,
call
yes.
that as a scale diagram. So 1 centimeter is 1 Newton. So 9 Newton will be 9 centimeter, 15 Newton, 15 centimeter. Or another student, instead of selecting 1 centimeter is 1 Newton, another student selected 1 centimeter is equals to 2 Newton. So 1 centimeter is 2 Newton. So 9 Newton will be how much? It will be 4.5 centimeter. And 15 Newton will be how much? If 1 centimeter is 2 Newton, you can use this as a ratio. If 1 centimeter represents 2 Newton, so 15 will be x. Cross multiply. So 15 divided by 2, it will be 7.5 centimeter. So this is one scale. Or another student select another scale. So it does not make difference to the final answer. A student select 1
So, Mister,
centimeter.
how we can make it, like how to measure it?
How to measure it? It's by a ruler. How to select a scale, that is the thing, that when you select a scale, it depends on you. It depends on your understanding, like what scale I should select, so that the length which I'm drawing for the lines, it will not be too big or it will not be too small. So if I select 1 centimeter is 3 Newton, so 9 Newton will be how much? If 1 centimeter is 3 Newton, 9 Newton will be
Will be three
Confirm.
3
3
centimeters.
centimeter. And 15 Newton will be how much? If 1 centimeter is
Will be
3
5
Newton,
centimeters.
it will be 5 centimeter. So
We
you
will
can,
we will divide it by 3.
yeah, we'll divide by 3. So it's up to you. Any scale you can select. It will not make difference. But it should be a scale which will not have a too small lines or not too big lines. So first point, we select a suitable scale. Is it clear? The first point.
Yes,
Yes.
sir.
Now, the second point, because we are using a parallelogram method, so we will mark a point to start both vectors from same point. So that is the second. We'll mark a point. So example, I mark anywhere I can mark. Example, I mark a point. I mark here. That's a point I mark. To start the both vector from the same point. So we want to start both vector from same point. So I mark that as a starting point. 9 Newton is there. So 9 Newton means how many centimeter? 3 centimeter. So I will place a ruler. Accordingly, I will place a ruler and I will draw 3 centimeter line. So I draw 3 centimeter line. Is it clear? Because
Yes.
the 9, we will redraw the figure again now. So 9 Newton is 3 centimeter. That's why I'm drawing 3 centimeter line. Is it clear to everyone? It's up to you. It's not necessary that you draw 3 centimeter first. You can draw a 15 Newton is there. So 15 Newton is 5 centimeters. So example, student first draw 5 centimeter. So it's up to you. Any one of them, any one of the vector, you will draw first. So first what we did, we mark a point, we mark a starting point, and we have to draw both vectors from this point. So any one of the vector we can draw 9 centimeter first, or we can draw 15 centimeter, 15 Newton first. So 9 Newton, which is 3 centimeter, and 15 Newton is 5 centimeter. So first what we did, we draw any one of them. I draw example, I prefer to draw a longer vector first. So example, I draw 5 centimeter first, according to the same as the direction which is shown. So I will draw, I will place my ruler or the scale at this point, and when it is 5 centimeter, I will draw a line. Is it clear this point? Any doubt?
Yes.
Yes, sir.
Thank you.
Now, what is the angle between them? 60. So how we measure an angle? So to measure the angle, we will place a D in a geometry box. You will find this D. So you will place a D here. On the line, you will place the D. And there are angles written on D, like 10 is there, 20, 30, 40, 50, and 60. So we will place a D here on the line. The center of the D is there on the starting point, and you place it on the line where the angle is 60. You will draw the second line, which is 9 Newton or 3 centimeter. So we'll draw a second line of 3 centimeter at an angle of 60 degrees. So this is how we draw the second line, 3 centimeter. Is it clear? The second point?
Yes, sir, clear.
Yes.
Anyone having a doubt or a question?
No, thank you.
So first what we did, we draw 5 centimeter, and then we draw 3 centimeter, and 3 centimeter, because the angle between them is 60 degrees, that's why we mark 60 degrees on the protector first, and then we draw a line of 3 centimeter at an angle of 60 degrees. Now this is called a parallelogram method. So we have to complete a parallelogram. So how we complete a parallelogram? We'll draw a parallelogram, means parallel line. So what we do, we will draw the 5 centimeter is there. So we'll draw another line of 5 centimeter. Because we have to complete a parallelogram. So the two vectors are there. We'll draw another line of 5 centimeter. And the parallel to 3 centimeter, we'll draw another line of 3 centimeter. To make a parallelogram. Is it clear? The second part. Then we
Yes.
complete a parallelogram. The third part, basically, what we did, we complete a so it was we were having two vectors like this. We mark the angle between them. We draw the two vectors in terms of centimeter. Then after that, what we did, we complete a parallelogram. How to complete a parallelogram? Parallelogram will have parallel side. So if this is 3 centimeter, we'll draw 3 centimeter side parallel. And this is 5 centimeter, we'll draw 5 centimeter side parallel, right? Both the sides should be parallel to the adjacent one. So we completed a parallelogram. This is 5 centimeter. This is 3 centimeter. Now what is the resultant? The diagonal of the parallelogram is the resultant. So when we draw the diagonal, how we draw the diagonal? So this is a diagonal. So we draw this diagonal, and when we draw this diagonal, what we call this diagonal? This diagonal is known as resultant. And how we will get this resultant? So what we do, we'll measure the length using a ruler or the scale. We'll measure the length of the resultant. Example, this resultant was, say, 7 centimeter. Example. So if this resultant is 7 centimeter, and we have the scale that according to the original scale, 1 centimeter is equals to 3 Newton. So if there is 7 centimeter resultant, how many newtons will be there? X. Cross multiply, 7 multiplied by 3. So the resultant is how much? The resultant is 21 Newton. So the resultant force of 15 and 9 Newton is 21 Newton when they are making an angle 60 degrees. Is it clear, this method of scale diagram using a parallelogram method?
Sir, I didn't understand the last point, which is
Yeah.
the diagonal of parallelogram is a result. Is the result?
Yeah. What does it mean? Because our main purpose to do this is to find the resultant of the vector. So this is a parallelogram. So what is the resultant here? What is the result of these two vectors? So when we draw the diagonal, what is the diagonal? The line which cut the figure into two halves, that is called a diagonal. So when we draw a line from one corner to another, we call this line as a diagonal. So we have the parallelogram. So we draw the diagonal from one end to another, from the starting point till the other side, other corner. This is called a diagonal. And this diagonal is representing what? This is representing the resultant or result of the two vectors. But this diagonal will not be in Newton, it will be in centimeter, because we are doing the measurement in centimeter. So this, when we measure the length of this resultant, it is coming out as 7 centimeter. Example. So if it is 7 centimeter and we know the scale that 1 centimeter is equivalent to 3 Newton. So if there is a 7 centimeter, what will be the result? It will be x. So cross multiply 7 multiplied by 3. So the resultant is 21 Newton. So 7 centimeter is actually representing the resultant of 21 Newtons. So whenever you're using a scale diagram, the diagonal of the diagram or the parallelogram is representing the resultant. Is it clear now?
Yes.
So I will do another example. So we have two vectors. One is 100 Newton. Another one is 150 Newton. So here, when we are finding the resultant, just a minute, I'll repeat the last part. Look what we did. We got the parallelogram. We drew a figure which was having a length. This was 3 centimeter and this was 5 centimeter. Then we completed the parallelogram. How we completed a parallelogram? We draw parallel lines to complete a parallelogram. Then after completing a parallelogram, that we draw the diagonal from the starting point where we start the both vector to the other side. We draw this diagonal, and this diagonal is known as the resultant. So what we do, we measure the length using a ruler or the scale. We'll measure the length of this diagonal. Example, the length of the diagonal is 7 centimeter. So if the resultant length is 7 centimeter, but we need our final answer to be in Newton. So what is our first scale? Our first scale was 1 centimeter is 3 Newton. So if 1 centimeter is equals to 3 Newton, so if it was 7 centimeter, how many Newtons will be there? X. Cross multiply, so 7 multiplied by 3, that is equals to 21. So this 7 centimeter is actually equal to 21 Newton. So resultant of the vector here is 21 Newtons. Is it clear now? So another example. Another example, you have two vectors. One is 150 Newton and the other one is say 100 Newton. What is the, we need the resultant, because, and the angle between them, example, it is 80 degrees. So 100 Newton and 150 Newton making an angle 80 degree. How we can find the result here? We have to use a scale diagram. So first what we do, we select a suitable scale. So it's up to you. Example, I select 1 centimeter is equals to I select example, it's equal to 20 newtons. Example. So 1 centimeter is 20 Newton. 100 Newton will be how many centimeters?
Will be 100 by 20, I think. Oh, 100 divided 20.
4. 5.
100 divided by 20. 1
It's
centimeter
5.
is 5. And if it is 150 Newton, so 150 divided by 20, it will be 7.5. So what we did, we select a scale. Is it clear, the first part? We select a suitable scale.
Yes.
Then we will mark a point to start the vector. Example, I mark this point to start my vector. 150 Newton. 150 Newton means 7.5 centimeters. So first I will draw and try to draw in the same manner 7.5 without making any measuring any angle. We just draw 7.5 centimeter. Then what is the angle between them? This angle looks more than 90. So example, this angle is 110. So what we do now, after drawing the 150 Newton, which is 7.5 centimeter, we'll place a D here, which is having the numbers. Angles are written 10, 20, 30, 40, 50, 60, 70, 80, 90 will be here. Then 100 and 110. So this will be 110. So when we place on the line, we read that as 0 and then 210. That because the angle is 110 and that is 100 Newton. 100 Newton means 5 centimeters. So I have to draw a line which is 5 centimeters. So from the same starting point, I will draw a line of 5 centimeters. Is it clear?
Yes.
Any doubt till this point?
No, thank you.
Now we will complete a parallelogram. So to complete a parallelogram, we have to draw the parallel lines. So we'll draw parallel line. For this, you can use a compass as well. I will show in the next session how a compass can be used to do this. So example, this is 5 centimeter. So we'll draw a 5 centimeter parallel line and we'll draw a 7.5 centimeter parallel line. It should be straight line. So we draw 7.5 and we draw 5 centimeter parallel lines. So this is 7.5 and this one is 5. Now to get the result, what is the result? From the starting point to the opposite corner, that is the diagonal, and the diagonal represent what? It represent the resultant. So what we do, we measure the length of the resultant. Example, when you measure the length of this resultant, say it was coming out as 6.2 centimeter. So if it is coming out at 6.2 centimeter, so what is the value? We know 1 centimeter is equals to 20 newtons according to our scale. So if there is a 6.2 centimeter, how many newtons will be there? X. Cross multiply 6.2 multiplied by 20. What is the answer?
124.
124. So it means the result here, the result is 124 newtons. Is it clear, this question?
Yes.
Then how the exam style questions, how you'll find these questions in exam? I will show you how the question. There's a separate sheet I prepare for these type of questions. So these are the exam style questions. You can see they mention two forces are there, 30,000 Newton and 20,000 Newton, which are making angle 20. What you need, by using a scale diagram, we have to find the resultant. So first thing, we have to select a scale. I think in this question, yeah, the scale is not given. So first we have to select a scale 20,000 Newton and 30,000 Newton. A minute left, so I will share another link, and I will just today only I will solve this question with you, and the next session we'll do more questions from this topic. So I'll share another link to complete this discussion.
Okay.
Okay, sir.